Ever wished you could travel back in time? Well, today we kind of are, not literally, of course, but we're going way back to the early 1900s to explore European climate extremes,
Hmm.
all thanks to some incredible AI. This deep dive uses cutting-edge tech to reconstruct historical climate data, giving us a much clearer picture of the past than we've ever had before. We're diving into a recent scientific article that focuses on, well, how AI can actually rebuild climate records.
Mm-hmm.
Think of it like filling in those gaps in our knowledge, right?
Mm-hmm.
The researchers use data sets like HEDIX3, which is based on real-world observations of things like extreme temperatures, and ERA5, which is a super detailed data set that combines observations with climate models. So why go back in time with climate data anyway? Like, what's the point?
Well, it's all about context, really. Imagine trying to understand a heat wave today, right?
Yeah.
Is it truly unusual, or is it just part of a longer trend?
No, I see. Yeah.
By looking back over a century or more, we can see how extreme events fit into the bigger picture. And it helps us figure out if what we're seeing now is truly unprecedented, or if similar things happened in the past.
That makes a lot of sense. So how does this AI approach actually work? Like, what makes it better than, the traditional methods?
Well, think of it like this. Traditional methods are kind of like connecting the dots with straight lines.
Okay.
They give you a general idea of the picture, but they miss the finer details. AI, on the other hand, is able to see the curves and nuances. It's like filling in a puzzle with more pieces.
Right. Right.
The researchers trained the AI on tons of climate simulations, allowing it to learn the complex patterns of climate systems.
Okay, so the AI gets a crash course in climate history, so to speak,
Mm-hmm.
and then uses that knowledge to reconstruct the past.
Exactly. And it's especially impressive in places like early 20th century Europe where we have limited historical data.
Uh-huh.
That's where the AI really shines. They used a special type of AI model called a UNet architecture, which is great at recognizing patterns, kind of like a detective piecing together clues.
So what kind of things did this AI detective uncover? I bet it found some surprises.
Oh, absolutely. It revealed a level of detail we just couldn't get with traditional methods. For example, the AI gave us a much more vivid picture of the intense European heat wave of 1911.
You mean that scorching summer that made headlines across Europe?
That's the one.
I remember reading about that one, yeah.
Traditional data showed us it was hot, but the AI revealed just how intense and widespread it really was. And get this, we even see evidence of that heat wave in demographic data from the time, like increased death rates. It really brings home the real-world impact of these extreme events.
Wow, that's pretty incredible. The AI is not just filling in data, it's telling us a story about the past. It's almost like time travel. What other events did the AI shed light on?
Well, let's take a look at the flip side of the coin, the brutal 1929 cold spell that gripped Europe.
Okay, so how did the AI handle that event?
It showed us something really interesting. While Central Europe was in a deep freeze, places like North Africa and Scandinavia actually had relatively normal temperatures.
Oh, wow.
The AI was able to capture these regional variations, which helps us understand the complexity of climate events.
So you're telling me that during the same year, some parts of Europe were freezing while others were experiencing normal weather.
Exactly.
That's fascinating.
And what's even more remarkable is that this regional variation matches up perfectly with historical weather reports and even personal accounts from people who lived through it. The AI's reconstruction lines up with what people actually experienced on the ground, which gives us a lot of confidence in its accuracy. It's not just filling in gaps, it's giving us a more accurate picture of the past.
Okay, I'm starting to see why this AI approach is such a big deal. It's like having a high-definition lens on history.
Exactly. And this is just the beginning. The potential of this technology is huge, but I think it's time we move beyond Europe and explore the global implications of this AI-powered approach.
That sounds like a great place to pick up in part 2. See you there.
So imagine a world where we have these detailed climate records for every corner of the globe,
Yeah.
even for places where, historical data is scarce. Like, that's the potential of this AI tech.
You're talking about regions like Africa, right? I
Exactly.
remember reading that, reliable weather stations were few and far between there for a long time.
Yeah, and without that accurate historical data, it's really tough to understand, like, how climate change is impacting those regions
Right.
and what kind of, adaptation strategies are needed.
It's like trying to solve a puzzle with half the pieces missing, right?
Precisely. But this AI approach could help us fill in those missing pieces. We could finally get a clear picture of how climate extremes have affected different parts of Africa over the past century.
Yeah, that would be a game changer for, researchers and policymakers working on climate adaptation in those regions.
Absolutely. It could, revolutionize our understanding of regional climate impacts
Mm.
and help us make more informed decisions about things like water resource management, agriculture, and disaster preparedness.
So this AI isn't just a cool tool for looking back in time. It's also a powerful tool for shaping the future.
That's a great way to put it. By understanding the past, we can better prepare for the future.
This AI approach reminds me of that saying, those who cannot remember the past are condemned to repeat it.
Right.
Only in this case, it's more like those who cannot see the past are less prepared for the future.
I like that it captures the essence of what we're talking about here.
Okay, before we get too far ahead of ourselves, let's go back to the European examples for a second. You mentioned that the AI uncovered some surprises, even in well-studied regions like Europe.
Yes. For example, the AI revealed that scorching 1911 heat wave
Right.
was even more intense than traditional methods had suggested, especially in the Iberian Peninsula.
Wait, so the traditional methods actually underestimated the severity of that heat wave.
Mm-hmm.
How is that even possible?
Well, traditional methods often rely on a technique called angular distance weighting,
Okay.
which basically smooths out the data based on the distance between measurement points.
Uh-huh.
It works fine if you have a lot of data points that are, close together, but in data sparse regions, it can lead to an overly simplistic picture.
It's like trying to draw a detailed portrait with only a few broad strokes. You're going to miss a lot of the finer details.
That's a great analogy. The AI, on the other hand, doesn't just connect the dots. It paints a richer, more nuanced picture.
Right.
Because it was trained on vast amounts of climate simulation data, it can actually reconstruct those missing details. And in the case of the 1911 heat wave, it showed us that the heat was even more extreme than previously thought.
But it wasn't just a localized event, right?
Right.
Didn't the AI show that it extended across a large area?
You're right. The AI revealed that the heat wave actually stretched across much of Western Europe, even reaching parts of North Africa.
Hmm.
That kind of spatial detail is really important for understanding the full impact of these events.
So the AI is like a climate detective, piecing together clues from the past to reveal the full story. I'm starting to think we should give this AI a name. What about Sherlock Climate?
I like it.
Sherlock Climate, the super sleuth of climate history.
Maybe we can workshop that name later.
Okay, but speaking of detective work, the AI also uncovered some interesting things about the 1929 cold spell, right?
Yes, it revealed a fascinating pattern of regional variation. Remember how we talked about the AI showing that North Africa had normal temperatures during that time?
Yeah, well, Central Europe was experiencing, record lows.
Right.
That was a surprising detail.
Well, the AI showed us that this pattern of variation was actually quite widespread. While Central Europe was in a deep freeze, places like Scandinavia and the Iberian Peninsula experienced relatively normal temperatures.
So even during this, major cold spell, there were pockets of Europe that were relatively unaffected.
Exactly.
That's really interesting.
And what's even more compelling is that this regional variation is corroborated by historical weather reports and even anecdotal accounts from people who lived through it.
Wow.
The AI's reconstruction matches up remarkably well with what people actually experienced on the ground.
That's like the AI is giving a voice to the past,
Yeah.
allowing us to hear the stories of those who lived through these extraordinary climate events.
That's a beautiful way to put it, and it highlights the real power of this technology.
Right.
It's not just about data, it's about understanding our shared history and how we've been shaped by the forces of nature.
Okay, I'm ready for more Sherlock climate revelations. What else did the AI uncover about Europe's climate past?
Well, when the researchers looked at long-term trends in the frequency of hot days, they found some interesting patterns.
You mean like how often those really scorching days occurred?
Exactly.
I'm curious to hear what they learned.
The AI revealed that the frequency of hot days has been increasing more dramatically in certain parts of Europe compared to others. For example, Central Europe and the Baltic Sea region have seen a much sharper increase in hot days over the past century.
So even within Europe, there are regional differences in how climate change is playing out.
Exactly. And that's crucial information for policymakers and planners. They need to understand these regional variations in order to develop, effective adaptation strategies.
It's like having a customized climate change roadmap for each region.
That's a great way to think about it.
This is all so fascinating. I feel like we've just scratched the surface of what this AI can tell us. What other secrets do you think Sherlock Climate is hiding?
I have a feeling we'll be uncovering those secrets for years to come. But for now, let's shift gears and explore how this AI approach is changing the way we think about responsibility and action in the face of climate change.
All right, so we've traveled back in time with this amazing AI, and we've seen that 1911 heat wave in a whole new light, and we even learned about those regional variations in the 1929 cold spell. But here's the big question. Now that we can, like, see the past so clearly, does it change how we should think about the future?
That is a really important question, and I think the answer is a resounding yes. For a long time, we've relied on climate models to try to predict, what the future holds.
Right.
And those models are incredibly powerful tools, but they're only as good as the data that we feed them. This AI approach gives us a chance to dramatically improve those models
Okay.
by giving them a much more accurate and detailed picture of the past. It's like
Yeah.
giving them a better textbook to study from.
So it's not just about looking back, it's about using the past to, like, sharpen our vision of the future.
Exactly. By understanding how climate extremes have played out in different regions, over the past century, we can get a better handle on what might be in store for those regions as the planet continues to warm.
That makes sense. So what are the practical implications of this? How can this AI-powered knowledge actually help us, prepare for the future?
Well, let's imagine you're a city planner in a coastal region
Okay.
that's vulnerable to sea level rise. Having access to this AI-generated data could allow you to see how past sea level changes have impacted your region
Mhm.
and use that information to make smarter decisions about infrastructure, zoning, and disaster preparedness.
So you're saying that this AI could help us build more resilient cities and communities?
Absolutely. And it's not just about cities, Think about agriculture.
Yeah.
This AI could help farmers understand how climate change has affected crop yields in their region over the past century
Right.
and use that info to choose crops that are more likely to thrive in a warmer future.
It sounds like this AI could have a huge impact on food security as well.
I think so. And let's not forget about water resource management. In many parts of the world, water is already a scarce resource,
Yeah.
and climate change is only going to make things more challenging. This AI could help us understand how past climate extremes have affected water availability and use that knowledge to develop more sustainable water management practices.
It's like we're finally getting the tools we need to make informed decisions about how to adapt to a changing climate.
I think that's a great way to put it. We're moving from a place of uncertainty to a place of greater knowledge and understanding.
Right.
And that's a really empowering shift.
Okay, I'm convinced this AI is a game changer. But I have to ask, are there any potential downsides? Are there any risks we need to be aware of as we start using this technology more widely?
That's a great question. And it's important to remember that no technology is perfect. One potential risk is that we could become overly reliant on the AI's predictions and lose sight of the need for, human judgment and critical thinking.
So we can't just blindly follow the AI's lead. We still need to use our own brains.
Exactly. The AI is a powerful tool, but it's just that, a tool. It's up to us to use it wisely and responsibly.
It makes a lot of sense. So where do we go from here? What are the next steps in this AI-powered climate journey?
Well, I think the most exciting thing is that this is just the beginning. As the technology continues to improve, we can expect, even more remarkable insights into our planet's climate history. And as we gather more data from around the world, we can start to create a truly global picture of climate change and its impacts.
So the journey back in time is also a journey forward.
Exactly. By understanding where we've been, we can better chart a course for where we want to go.
I love that. It's a message of hope and empowerment. So for all of you listening out there, I encourage you to check out the maps and visuals from this study. We'll link them in the show notes. Take a look at what the AI revealed for your region. You might be surprised by what you discover. And remember, even though we're talking about, some pretty complex science here, the message is simple. The more we know about our planet's past, the better equipped we are to face its future. That's it for this deep dive into the world of AI and climate science. We'll be back soon with another fascinating topic. Until then, keep exploring, keep learning, and keep asking those big questions.